Hello everyone, welcome to all in this video lecture series of Database Management System. I am Deepak Aneja, Assistant Professor, ABS Engineering College, Ghaziabad. Today in this video, we will understand the concept of normal forms. Here we will cover third normal form and BCNF, Boyce Code Normal Form. In the previous video, we have already covered the 2NF, but still there is some redundancy left in 2NF, but still it may suffer from the inconsistency problem that will arising insert, delete and update anomalies. Let us understand this anomaly concept via this example. Suppose there is a student table. Attributes are student ID, student name, age, city and pin code. Now, here we will see the candidate key is student ID. So here is a single attribute candidate key. So we can see that this table is in 2NF, but still there is some update anomalies left in this table. As you can see that student ID determine pin code and city is dependent on pin code or you can say pin code determine city. So here prime attribute is student ID and non-prime attributes are student name, age, city and pin code. As we can see that non-prime attribute determines the non-prime attribute and candidate key will determine a non-prime attribute. So this is valid, but a non-prime attribute determining non-prime attribute, there is transitive dependency. As we have already studied, what is transitive dependency? If A determine B, if it holds, then B determines C, then through the law of transitivity, we can say that A determines C. So here, candidate key will determine a non-prime attribute and a non-prime attribute determining a non-prime attribute. So here is update anomalies left, as there is lots of updation required in the city if we update it in the city. So we need to remove such anomaly by progressing the third normal form. So what is this 3NF? A table or relation is in 3NF if and only if. The first condition is a table or relation must be in 2NF and there should be no transitive dependency. There should be no transitive dependency, as we have already discussed the student ID determining pin code and pin code determining city. Here the candidate key is student ID and prime attribute are student ID and non-prime attributes are pin code and city. So here is transitive dependency. So this relation is not in 3NF. So let us understand this concept with a trick that left hand side must be a candidate key or super key. Super key is the minimal set of candidate key. Here is or right hand side, right hand side must be a prime attribute. This is the condition for no transitivity for 3NF. Or there is logical or. Logical or means true, 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 false, true, true, and false, false, false. So in case of true, this is in 3NF, or in case of false, there is not in 3NF. So what this condition says, either left hand side must be the candidate key or super key, or right hand side must be a prime attribute. Non prime attribute does not determine the known prime attribute, or non prime attribute can't determine the known prime attribute. Now let us understand this concept via this example. Let us take a relation R ABCD with the functional dependency set A determine B, B determine C, and C determine D. Let us find this relation is in 3NF or no. So step 1 is to find the candidate key. So same process to calculate the candidate key, the missing attributes B, C, and D. Here the missing attribute is A. We have to take the closure set of A. From A, we can determine A to B, B to C, and C to D. So A is the candidate key. Here prime attributes are, step 2 is to find out the prime attribute. Prime attributes are A, and step 3 is known prime attributes. To find the known prime attributes, known prime attributes are B, C, and D. Now check for 3NF. Here is the functional dependencies that are given. If any of the functional dependency is not in 3NF, so we can say that the whole relation is not in 3NF. Now check for the condition. Left hand side should be the candidate key or super key, or candidate key, super key, or right hand side should be the prime attribute. So A. A is the candidate key. Yes, true. Or if this is true, then B is non-prime attribute. This is false. True, false is true. So we can say that this is in 3NF. Now check for B determine C. B is the candidate key. No, this is not the candidate key. Or C. C is the prime attribute. No, C is the non-prime attribute. So through this is the false, or we can say that this functional dependency is not in 3NF. If a single functional dependency is in not in 3NF, then we can say that the whole relation is not in 3NF. Now check for C determine C. Now check for this. C is the candidate key, false, or D is the prime attribute, false. This is false. So this is also not in 3NF. So we can say that the whole relation is not in 3NF, third normal. Now let us take one more example. R is a relation ABCD with the functional dependency set AB determine CD and D determine A. Now let us find is if this relation is in 3NF or not. Now first step is to find out the candidate key. Same procedure, CD, CD, here, A, A. The missing attribute is B. We have to take the closure set of B. From B, we can determine this B, and B we cannot determine further. So we have to make the combination with the B. So AB, BC, AB, BC, BD. Now take the attribute closure of this AB to AB, we can determine CD. So AB is the candidate key. Now check further. BC, we can determine BC. From BC, we cannot determine further. So this will not be the. Now check for BD. BD further from D to A and AB to CD. So BD is also the candidate key. Now prime attributes are, there is no further functional dependency, sorry, no further attribute left. So there will be no further candidate key. Now the prime attributes are A, B, and D, and non-prime attributes are only C. Now take the functional dependencies given functional A. B determines CD and D determine A. Check for 3NF. Now left hand side should be the candidate key or super key, or right hand side should be the prime attribute. अगर दोनों में से if from the both one condition is true, then we can say the given functional dependency is in 3NF. Now check for this AB. AB is the candidate key, true, or CD. C is the non-prime attribute and D is the prime attribute. So we will consider this in non-prime attribute. So uh, uh, this is false. This is non-prime attribute. So true or false is true. So this is in 3NF. Now check for D determines A. D is the candidate key. No, this is false. Or A. A is the prime attribute. True. This is the prime attribute. True. False or true is true. So we can say that this is in 3NF. So the whole relation is in third normal form. So I hope you will understand this concept of 3NF. Now next is BCNF, Boyce code normal form. This is the extension to 3NF. This is also known as 3.5 normal form. Some redundancy might still remain even after a relation is in 3NF. So a table or relation is in BCNF if and only if table or relation must be in 3NF, and for each non-trivial functional dependency X determines Y, X should be the candidate key or super key. So left hand side must be the candidate key. So that's why it is more restrictive. There is no further option. Only it depends every attribute or every functional dependency that is determined that is determined by candidate key, that is dependent on candidate key. For example, there is a student relation. Attributes are roll number, student name, Aadhaar number, age. Here we can see that the candidate key is roll number or Aadhaar number. So here roll number and Aadhaar number are the candidate key. So roll number determines student name, roll number determine age, Aadhaar number determines student name, Aadhaar number determine age. So this is the candidate key. So this is in BCNF. This is also the candidate key. So this is also in BCNF. Now check for this. Aadhaar number is also the candidate key. So this is also in BCNF. Now check for this functional dependency. This is the also the candidate key. So this is also in BCNF. So we can say that this table or relation is in BCNF. Now let us understand this concept with this example. Relation R ABC with the functional dependency set AB determines C, C determine B. Let us find this relation is in BCNF or not. Now, first step, we have to find the candidate key. Now, C, B, B. Missing attribute is A. We will take the attribute closer. From A, we will determine A, and further, we cannot determine anything else from A. Now, we have to make the pair with A, B, and then AC. With the missing attribute. We have to make the pair with the missing attribute. Here, missing attribute is A, so we will make the combination with AB and AC. Now take the attribute closure of this. We can determine AB, and from AB we will determine C. So the candidate key is AB, and check for AC. From AC we will determine AC, and from C we will determine B. So this is also the candidate key. Now the prime attribute A, B, and C, known prime attribute. There is null, no known prime attribute. Now check for the function given functional dependency for BCNF. The left hand side should be the candidate key. So this is true. So we can say that this functional dependency is in BCNF. Now check for this functional dependency. Left hand side should be the candidate key. C is the candidate key. No, false. So this is not in BCNF. So we can say that the given relation is not in Boy's code normal form. I hope you will understand this concept of Boy's code normal form. So these are the references. Thanks for watching this video.